Guys, this is the episode 2 for physics 102, and if you check this question very well, you notice that it is a question on infinitely long line charge. That is, we have the linear density. Lambda is representing linear density. We have linear density, we have area density, and we also have volume density. So these are the three different type of densities that we have as far as charge with density is concerned. So we are asked to calculate the electric field at a specific distance. So the distance is given as 5 centimeter, the distance between the electric charges, right? So the distance between the two electric charges is given as 5 centimeter, and we are asked to calculate the electric field between the two. So what we are going to use is we are going to use electric field due to an infinitely long line charge wire. So, and it has a different formula from the normal electric field formula. So we have E to be equals to lambda over 2 pi E naught R, and the value for E naught is 8.85 times 10 raised to power minus 12. That's the electric field constant. And since the distance is already given as 5 centimeter, we impute all our respective parameters, and we have our final answer to be 152,000 Newton coulombs. So our final answer is 152,000 Newton coulomb. So that is the electric field at distance of 5 centimeter. Don't forget that the distance is also imputed. We have 2 pi times 8.85 times 0.05. We convert the distance. I didn't put it there, so just make sure that you put the distance there. The distance is 0.05 converted to meter. So our final answer is going to be 152 Newton coulomb. So that is that for question number 1. So we are moving down to question number 2 now. Now, question number 2 is we have a rectangular coordinate system. So the software I'm using to do this video do not permit me to make a construction. We have a diagrammatical representation for this question. So we have a rectangular coordinate system, and we have a charge of 25 times 10 raised to power minus 19 coulomb. We have two different charges, charge 1 and charge 2, and you notice that the two charges, they are of the same value. So, and they are placed between a distance of x equals to 5 meter and y equals to 0 meter. So we are going to draw a diagram for the x-axis and for the y-axis. So what the question says is that we should calculate the force that is between these two charges, and we should state whether it is repulsive or attractive. Now let's quickly answer that. Now, since the two charges are positive, and you know that when two charges come together, when two positive charges comes together, what happens is repulsion, right? There is no attraction between these two charges. So we've answered that part already. So it is a repulsive force. Now we are going to calculate the force given the two charges. We have K to be 9 times 10 raised to power 9 and Q1 to be 25 times 10 raised to power minus 19. At the end of the day, we have our final answer to be 1.87. Meanwhile, now since this is a coordinate system and we have x-axis and y-axis, so what we need to do is to find the resultant of the distance. So we take the resultant of the distance, that's 5 squared plus 0 squared, which is 25, and that is going to be the distance between the two charges. So that is that for the force. Now the B part says that we should find the electric field intensity at point 2.5, and you know that since it is two different charges, we have electric field intensity for the first one, we also have electric field intensity for the second one. So, and our distance, just like what we did in the first part, we look for the resultant of the distance, which is r to be 2.5 squared plus 0 squared which is equals to 5. Now there's what we call point charges. In physics, there's something we call point charges. So those point charges, whenever you see an electric field with a unit vector, that r that is having a dot on top is a unit vector alongside the electric field. This is what we refer to as point charges. So since it is two different point charges, we calculate them respectively, and we have the electric field intensity to be 0.75 times 10 raised to power 3 Newton coulomb. So that's that for question number 3. Now question number 2. So let's move down to question number 3. Alright, so guys, now we have question number 3. Question number 3, we have two different charges, three different charges in this case. So we have Q1, Q2, and Q3, and their respective values are being given. Now they want us to find the S component of the resultant force on Q1, and they also want us to find the resultant force. Now to find the resultant force, assuming the software I'm using do not permit me to give a diagrammatical representation for this, we have two charges lying on the x-axis as separated by distance. So another charge Q3, so we'll be having a triangular diagram, Q1, Q2, and Q3. So they want us to find the resultant force on Q1, and they also want us to find the general resultant force. Now to find that simply means that we are going to find the force on charge 1 and charge 2, and the force on charge 1 and charge 3, since it is a triangle we are constructing. So we find F12 and F13, that is the distance, the charge between Q1 and Q2. So we have two different charges between the first force, and the Q1 and Q3 between the second force. So we use the general Coulomb's law method. So using the Coulomb's law, we have K equals to Q1 over Q1 Q2 over R squared, and we have our respective values, Q1 and Q2 and R. So for the first one, we have 3.6 times 10 raised to power minus 3. For the second one, we have 5.8 times 10 raised to power minus 4. Now to look for the resultant, since this is a vector, we take the resultant of the vector for the first of the two forces, F12 and F13, and we have our final answer to be 3.6. Assuming the question says that you should find the angle between the two forces, or between the two forces, yes. So that's going to be inverse tan of F13 over F12, and you have your answer in degree. So quickly, let's move down to question number 4. So we have question number 4, and we have two different charges, Q1 and Q2, and they are separated by a distance of 10 centimeter, and we are asked to find the distance from Q1 if the electric field is equals to 0. So they want us to find the distance if the electric field is 0. Now the truth of the matter is that we have two different charges, and we are told that they are separated by 10 centimeter. Now we know the distance of Q1 to be 10 centimeter, but the distance of Q2 is unknown. So what we do is that we subtract the distance of Q1 from the distance of Q2 to get the distance of Q2. So that's why we have D minus R and R. So the distance of Q1 is R, the distance of Q2 is D minus R. But don't forget that they gave us one of the distance, which is 10 centimeter. So what we do in this case is that we use the electric line of force formula for two different distance. So we have E equals to KQ over R squared. So we subtract the second one from the first one, right? So if on subtraction, and we equate the electric field to be 0, since it was stated that the electric field is equals to 0, so we make R the subject of the formula. So 1 over 4 pi E naught cancels out, because when we cross multiply it becomes 0. So we are left with Q1 over R squared equals to Q2 over D minus R squared, and Q1 is already given, Q2 as well is already given, and the distance itself is already given. So we convert the distance to meter, and that becomes 0.1. And when we make R the subject of the formula, we have R to be 0.05. Now when we get our distance, we subtract the distance which was given, as 10 minus 0.05, assuming it is the second one they want us to find. It's going to be 10 minus 0.05, but if it is R we are finding, the value for R is 0.05 meter. So let's move down to the last question for this episode. So the last question for this episode says that we should calculate the electric field at a distance of 320 centimeter from an infinitely long wire carrying a charge density of 8.3 coulomb per meter. Now the unit for charge density is coulomb per meter, so kindly change that. The lambda is meant to be 8.3 coulomb per meter, so that's charge density. Recall that we did something like this in the first part, in the first question we solved. So when we insert all of the necessary parameters, we have the electric field to be 148.8 C 8 Newton coulomb. So that is the end of this episode. So if you've been viewing all our videos and you've been viewing all our episodes, I will advise that you click on the subscribe button so you get notified when other episodes are dropped. All right, thank you.